An interface is a contract with the class. Contracts are agreements for doing something or not doing something. So the contract between an interface and class is the interface specifies what a class must do, but not how the class must do it. Here is the syntax for an interface. All interfaces have the keyword interface before the interface name. The scope must be public or package. In this example, the scope is public, but if we do not define a scope, then the default scope is package. Every field in an interface must have a constant value. Therefore, the variable is implicitly public, static, final, and requires a value. In this example, I did not include those three keywords, public, static, or final. However, Java will still treat int hours in a day equal to 24 as a constant because interfaces are contracts that cannot hold state. That means not allowed to change its behavior. So we should not add a variable if the value is going to change. When it comes to methods, they cannot be abstract, static, or default to an implementation. Notice the method void calculate hours does not include the abstract keyword and it does not include a body. It does not include abstract or a body because the interface assumes all methods are abstract. As a result, the abstract keyword is not required. Since the interface has a contract with the class, there is a guarantee that each abstract method listed in an interface will be implemented by the class. Static methods and default methods are not required to be implemented by a class because they already have an implementation. Two of the benefits for using an interface is to bring consistency for all classes that implement an interface and the support of multiple implementation. My plan is to demo both benefits by starting with consistency for all classes. Let's look at two email service providers, Outlook and Gmail. With Outlook, we see a lot of functions such as file, home, send and receive, folder, view, and help. If we wanted to create a new email, we can click New Email. If we wanted to close, we can click X in the top right corner or go to File, then click Exit. Those same functions are available with Gmail and other email service providers. In Gmail, to create a new email, we select Compose. It's the same function in Outlook, but just a different name. The spam folder is used to store emails that we don't want in our inbox. Outlook has this same function, but it's called junk. Although both providers have functions that operate the same, the name is different and implementation details are different. For consistency, we can create an interface so Outlook and Gmail have the same name with their own unique implementation. Outlook has three methods: new email message, open junk folder, and close Outlook. Gmail also has three methods, but different names: compose email, open spam folder, and close Gmail. Recall from the introduction, An interface is a contract with the class. It's an agreement that determines what a class must do, but not how the class must do it. Therefore, both classes will have the same method name, but different details. To create an interface, we go to New, Interface. The name will be Email Service Provider. Then click Finish. It looks like a class, but we see public interface and not public class. We create a method by writing public void, then the method name, create email message, add a semicolon. Writing keyword abstract after public is optional. As a convention, we do not write abstract. It's an assumption that all methods in an interface are abstract, although we can write default methods and static methods. For example, if I remove the semicolon, then add a body which start and stop with the curly braces. An error states, abstract methods do not specify a body, but it shows us 3 quick fixes, which include changing the method to default or static. Remove the braces, then add back the semicolon. Abstract methods define the signature of a method, but no implementation for the method. Some more methods that we can add to this interface are public void open junk spam folder and public void close email provider. So this interface says all implementation classes should be able to create an email message, open a junk spam folder, and close the email provider. Now let's implement the interface. Go to Outlook and write implements email service provider. Instantly, we see an error. The type Outlook must implement the inherited abstract method email service provider. Open junk spam folder. All 3 methods are recognized as an abstract method. The 2 quick fixes are add unimplemented methods and make type Outlook abstract. Let's add the unimplemented methods. We see each method from the interface email service provider with an override annotation. This is where the Outlook class can implement its unique details for each method. I'm going to copy and paste the print statements. Outlook new email. Outlook open junk folder. And Outlook close email. The same for Gmail. It implements email service provider. And this time, let's make the type abstract. The keyword abstract is added before class. We should not make the class abstract because it can lead to an error when creating an object. Objects cannot instantiate an abstract type. Remove abstract, save, then select add unimplemented methods. Also copy and paste the print statements Gmail compose email. That kind of rhyme, don't it? Gmail open spam folder. And Gmail close email provider. The contract agreement between the interface and each class has been fulfilled. Look what happens when the interface breaks the contract agreement by adding another abstract method. Public void save draft folder. Then click save. We see an error in the Outlook class and Gmail class. The error exists because both classes was now part of the original agreement with save draft folder. To solve this error, we can do one of two things. First, we can go to each implementation class and implement the abstract method. But what if our program had more than two classes? What if I wanted to add another method later on? I prefer option 2 and extend the interface. Java allows us to extend the interface so we don't have the fear of breaking an implementation class by creating a default method. The key is to add default and include a body. There will be an error if we only add default. The error states, this method requires a body instead of a semicolon. Add a print statement for the body, sysout, save, draft. Skip a line, then save. Both errors are gone, but if we wanted to, we could override the default method. However, when it comes to a static method, it provides a protection for an interface. It provides protection by not allowing an implementation class to override the static method. You can watch the Java bindings video where I speak about how Java restricts static methods from being overridden. We can write public void sent email folder. Public static void sent email folder. Sysout sent email. Let's test the interface and both implementation classes. Go to new class, main, test email service provider, then finish. Email service provider, object out look equals new outlook. Outlook dot. And we see 4 methods, all 3 abstract methods and the default method. Close email provider, create email message, open junk spam folder, and save draft folder. Select the open junk spam folder, but do you see how the static method is not here? Outlook dot. Create email message. Outlook dot. Close email provider. Outlook dot. Save draft folder. We can write the same for Gmail. Email service provider, Gmail equals new Gmail. Gmail dot open junk spam folder. Gmail dot create email message. Gmail dot close email provider. And Gmail dot save draft folder. Let's run. We see 8 methods, 8 print statements, 4 for Outlook and 4 for Gmail. Next, we're going to look at how interfaces support multiple implementation. Multiple implementation of interfaces is a way for a class to implement more than one interface. That's important because inheritance cannot extend more than one class, but an interface can extend more than one interface. In this diagram, we see one superclass and 3 subclasses. Each subclass inherits the superclass. Let's look at this diagram using a store example. Store is the parent class, while food store, clothes store, and medicine store are the child classes. With inheritance, there is no way to combine all stores into one combo store. It is impossible because we are not allowed to extend more than one class. This is called a diamond problem. Do you see the diamond? Combo store will not inherit food, clothes, or medicine, although it's possible in real life. However, we can combine all stores when one class, which is combo store, implements more than one store. There is no limit to the number of interfaces a class can implement. In Eclipse, we see the food store has 2 abstract methods: sell fruits and sell vegetables. The medicine store also has 2 abstract methods and 1 default method. Sell prescription and sell vitamins are the abstract methods. Pay cashier is the default method with details to pay a pharmacy technician. Clothes store is similar to medicine store. It has 2 abstract methods: sell shoes and sell shirts, and the same default method named pay cashier, but different implementation details. To combine all 3 interface stores, we go to the combo store. Then it implements food store, clothes store, and medicine store. Just like when implementing one interface, we must add all unimplemented methods. There should be 6 overridden methods: sell prescription, sell vitamins, sell shoes, sell shirts, sell fruits, and sell vegetables. Save, and there's one more error. Duplicate default methods named pay cashier with the parameters that's blank and are inherited from the types medicine store and clothes store. For a quick fix, we can override the default method name or change the parameters. This is also a diamond problem because both interfaces have the same default method name pay cashier, and the compiler cannot decide which super method to use. Override pay cashier from close store. Go to the method and we see override close store.super.payCashier. Recall that a class cannot extend more than one class, but an interface can extend more than one interface. Let's go to the food store interface. It extends another interface called email service provider, which is another interface from the previous session, how to implement an interface. Save and combo store will have a different error because the abstract methods from email service provider must be implemented. Add unimplemented methods. Then go to the bottom and we see each method. Create email message, open junk spam folder, and close email provider. In this example, multiple interfaces are extended after adding a comma and another interface name. The interface is day. It extends two interfaces, week and month. That completes the Java Object-Oriented Programming series. We covered 4 traits of the OOPS concept: encapsulation, inheritance, polymorphism, and abstraction. I hope you learned something from this OOPS series. If you did, subscribe, connect, and follow me because I have so much more content to share with our testing community. And I'll see you in the next video.
Books available in paperback, ebook, and PDF. All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's the Selenium Automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.